Okay, so like I said, okay, this is it. This is just a small information. Okay, how you can easily determine that a function is odd, okay, or even. If your function is a one-term, okay, or one variable term function or one-term function, okay, please take note. One variable term function or one-term function, you use the power of your variable to determine. If the power of the variable is even, then it means, okay, your function will be even. If the power of your variable is odd, it means, okay, the function will be odd. So you realize that, okay, this function is a one-term function, a one variable term function. Okay, one variable term function. However, the power here is even. The power for this one is also even. So you realize that when we were asked to make that determination, we found out that this function was even, this equally was even. Okay, and if you come to this one term, the power here 3 is odd. The power here 3 is odd. Okay, and you realize that the function ended up being was an odd function. Is my point well made? So if it's an objective question, okay, and you are asked to determine that and it's just a one-term variable function, please just look at it and pick the answer. Okay, so assuming maybe I give you, okay, these two functions, and I tell you, okay, which of the following function is odd, even. Okay, or let me say, if which of the following function is odd, obviously you come to the one with the odd power, and you pick that one as what odd. It is an objective question. Maybe I can say A, S cubed, okay, B, S to the power 6, C, S to the power 8. What have you? You have to know that the one with odd power will be odd. The one with even power will be what? Even. That is if it is just a one-term variable or a one variable term. Okay, so please take note. All right, so now let's look at the next one. Okay, so the D. I'm not going to do the D, okay, because you can easily do that. I've even told you that it will be. So it will be similar to what we just did. Okay, I mean here. Only that when you substitute, the first one will be 4 into negative x or 2, which will give you, okay, 4. So the first one will be 4 into negative x cubed, which gives you 4 into, you put the power inside, and that will give you negative x, okay, cubed. And you can remove the bracket, which gives you minus 4 x cubed. Should we do it or the point is well made? Who wants us to do it? Okay, so you are fine. Very good. So we can make that determination. It's just a matter of substituting and working with your algebra. So now I'm going to look at a situation where we have more than a term. So straight away, I'll move on to E. Okay, E, what are we giving? We are giving, okay, G, and you can see that the function came in the arrow form. However, remember, we'll extract in the relation form. So G of x is equal to 3x squared minus 1. Okay, so I, okay, we want to determine whether this function is what is even. Okay, so for G of x to be even, we know the condition. The condition is that G of minus x should be equal to G of x. Do you agree? Okay. All right. So please take note. This time I'm going to handle it in a different way. Okay. It's not totally different. I will change the side that I will start working with. Okay. And this is the reason why I'm going to swap. Usually, okay, for the even and even for the odd, this side is very easy to compute. Okay, which is the right-hand side of your condition, because this is just G of x. So you just copy and paste. You know your G of x there. Okay, so always, like I say, for me in math, I always write what will involve little or no work first before I go and deal with the one that I have to think, so that I will have ample time to think. So in this case, this is what I'm going to do. I'm going to take this side first. Okay, so taking, okay, g of x, and I know that that is equal to, okay, g of x is 3x squared minus 1. Okay, then I go and take the other side, because you can see that this one no input. So taking, okay, the other side, and the other side is g of minus x. So this one, there will be an input because it's not directly given. So you are going to find, okay, g of minus x. Wherever you see x in g of x, it is now minus x. So it means I'm going to get 3 into minus x, but it has a square. Okay, then minus 1. Hello, are you with me?
Yes, please.
Okay, so at this point, okay, please, order of operation, go and deal with the power first before you come and remove the bracket. So I will have 3, I will push the power inside, and minus x, okay, all squared will give me x squared, then minus 1. So I'll now come and remove the bracket. This gives me 3x squared minus 1. Is my point well made?
Yes. Yes, please.
Okay, so now we can compare the two. The two results, are they the same?
Yes, please.
Okay, so the obvious conclusion would be, therefore, our function g of x, okay, is what? Even. And you attach your reason. If possible. So that will give you terms g of minus x is equal to g of x. Any questions at this point? Okay, case here number 2. Case here with h. Okay, it seems your network is giving you an issue. Are you able to follow? Okay, work on your audio. I wouldn't be able to hear you. So fix your audio, then let me know if you are fine. Okay, so this will be it for the I. Now we move on to II. Okay, II for, okay, g of x to be odd. Okay, please, what is the condition? Can someone tell me the condition? Hello?
F
Can
of
someone tell me
minus
the
x.
condition? Hey, come again.
F of minus x.
No.
Sorry, G of minus x
Okay, so g of minus x
should be equal to minus G of x.
minus g of x. So this is the condition. Once you know this condition, the rest becomes trivial because it will just be evaluating. Take this, evaluate, take this one, then that will be it. Okay, so again, this is what I'm going to do because I found it. Okay, so now it's like this one is very easy because it will be copy and paste. But if you've not found it, this side will always be easy for you to deal with because it will be minus your original function. Okay, so you just multiply each of the terms, or okay, push the negative through, and that will be it. So again, I'm going to I've not done this side. So in my mind, I know that this is going to be the easy side to work with. So I will take that side. So taking, okay, minus g of x. So this would be equal to minus my g of x. So I put my g of x because it's a 2-term function, more than a term. I put it, I've even told you, even if it's a term, put it in brackets for safety reasons. So I'll get 3x squared minus 1, which in effect will come and give me minus, okay, 1 times, so which will give you minus 3x squared, then minus 1 times, okay, minus 1, that will give me plus 1. Is my point well made?
Yes, please.
Okay, I hope you can see this part of the board. Okay, once I can see it on the screen, then you should be able to see it. So that will be it for the right-hand side. I took the right-hand side. Okay. Now I'm now going to take the left-hand side. So taking, okay, the left-hand side, and the left-hand side is J of minus x. And with this one, because you've done it, don't go through the stress. Don't go through the stress. Okay, you know your result, where you land. So just pick it and write it there. So 3x squared, okay, then minus 1. If you've not done it, then you have to go through the process, okay, of obtaining this again. Okay, so at this point, if you compare, let's see, okay, all the first terms are not the same. For two expressions to be the same, they should have the same, first of all, number of terms and the same term. Okay, they have the same number of terms, but they don't have the same term. The first term here is 3x squared. The first term here is minus, okay, 3x squared. So once one term, okay, not the same, don't even go and look at the other term. It is necessary and sufficient for you to draw the conclusion that they are not the same. So in this case, what do we do? Therefore, the function g of x, okay, is not, okay, what do you call it? Odd. So attach your region. Okay, j of minus x is not equal to minus g of x. Is my point well made? Kezia, are you fine? Kezia with H.
Yes,
Kezia, are you fine?
Yes, please.
Okay, that's the Kezia without an H. Kezia with, are you fine? We seem you are talking, but I'm unable to hear you. I can only, Kezia, are you fine?
Yes, please.
Okay, we thank God. All right, so now let's move on. Okay, we've done E, so we are going to do F. Then, okay, so now F will be for you. Okay, so maybe we'll do J, then you will do. So the last question for all of us will be J for the, what do you call it? So again, if you look at this critically, this is a two-term, okay, function. However, remember I said concentrated is a two-term function, and you have only one term variable or one variable term. Okay, let me put it. If you have only one variable term, you can use the power to make that determination. So this, I have two terms, but there is only one variable term. Okay, which is this term. And the power here is 2. So it means my function, okay, will be even because the power, okay, of my variable in that term that contains, that only term that contains, okay, the variable is 2, which is what? Even. So my function will end up being even. It's my point well made. So assuming I give you maybe 4x cubed, okay, plus 5. Okay, what type of function would this be in terms of even and odd? By inspection, before you even start, it will be odd. Why?
Because the power is odd.
Because the power of the variable is odd, as simple as that. And there is only one term. However, if I give you, I think we are going to look at that. So let me move on before I think the leave out of my field. All right, so let's see. The next question, Jane. Okay, what are we giving? We've been given f of x, okay, is equal to x squared plus x minus 1. How many variable terms in this function?
2.
2. Okay, so let's see whether that information will still hold. Okay, remember I've only indirectly given you a hint already. Okay, all right, so let's go. So in this case, we are going to write for, okay, forgive me, f of x, okay, to be even. We know the condition f of minus x should be equal to f of x. So as usual, this side is very easy because it is cut and paste. Okay, so copy and paste. So what are we going to do? We are going to write taking, and I will take this side first. But I've told you it doesn't really matter. Only that I always want to work with the one that will involve little or no input. Okay, so taking f of x, I know that is equal to x squared plus x minus 1. And I'm going to take the other side too now, the one that will involve my input. That is f of minus x. And f of minus x means wherever I see x in f of x, it is minus x. So I can see I have two terms in x here. So each one will be minus x. So I'm going to get minus x but squared, then plus, okay, this one will also be minus x, then minus 1. It's my point well made. Hello, it's my point well made.
Yeah.
Okay, so at this point, you come and remove the power, the bracket, the coefficient is 1. So you move the power and the bracket together. So that will give us what? Minus x, okay, times minus x, which will give us what? X squared. Then this will give you this time, this, so which is minus x, then minus 1. Okay, so now, okay, that is it for, so you are going to compare. First term, the same. Second term, this is plus x, this is minus x, so you stop. It means these two expressions, okay, are not the same, or results are not the same. Once we have a term not being the same. So in this case, we draw the obvious conclusion. Therefore, the function, okay, so f of x, okay, is not, okay, even. And I've told you, the fact that it is not even doesn't make it automatically odd. Okay, I think so far that has been, okay, the line of what do you call it, direction, but that is not the case. Okay, all right, so we are going to look at the second situation, which is the II. So II, okay, for f of x, okay, to be odd, the condition is that f of minus x should be equal to minus f of x. Okay, so I'm going to take one of the side. Again, I'm going to assume I've not done this side. But if you have, this would be the previous side to work with it because you just copy and paste. But I'm just assuming. So I'll come and do this. Okay, so taking, okay, minus f of x. Okay, this will be equal to minus, what is my f of x? I put it in brackets. And my f of x is this. So it will be x squared, okay, plus x, then, sorry, minus 1. Then you close your bracket. Okay, so let me see. Can I continue here? Okay, so let me continue here. All right, so I'm going to see the continuation here. So please take note. All right, so here, what do I do? So that will be equal to, okay, I remove the bracket. So I'll get this time, this will give me minus x squared. This time, this which will give me minus x. This time, this which will give me plus 1. Okay, so let's check. Okay, this one ended up giving us, okay, I think I've done only one side. I haven't done the other side. So let's go and take the other side. So taking the other side, and the other side is what? F of what? Minus x. And we've done that one already. And that gave us f of minus x, gave us x squared minus x, then minus 1. So obviously, the first terms are not the same. Okay, so it means these two, again, are not the same. So you draw your conclusion. Therefore, your condition was not satisfied. So your function f of x is not, okay, odd. Okay, then you attach the reason. Since, okay, f of minus x, okay, is not equal to minus f of x. My point well made. Hello, it's my point well made.
Yes,
Yeah.
please.
Okay, very good. So it means this will be it for even and odd functions, how to make that determination. However, you can see that if your function, okay, contains more than a term, a variable term, okay, you cannot easily, okay, make that determination whether it is directly odd or what or even. So please take note. But usually it will not satisfy both. If it contains a mixture of the two, you have even power for one of them, then odd power for one of them. It cannot be even and odd. However, if you have odd powers for all your variable terms, so let's say s squared, okay, sorry, let me use s squared plus s to the power 4, then maybe minus 5. Because my variable terms, all of them, okay, they have even powers, okay, it is likely to be even. So if you like, go and investigate. So if I have x cubed, then maybe plus 2x, then maybe plus 4. Okay, because my variable term here, the power is odd. This one to the power is odd. It is more likely to be odd. It's my point well made. However, if it becomes a mixture of even and odd powers, then it is more likely, okay, not to be, okay, any of these two. Is that clear?
Yes.
Okay, very good. So please kindly take note. So this will be it for the even and odd. So let me capture and send it to you. Then we'll go and look at our next concept, which will be the one. Okay, so now we are going to look at our next type or our next special function, which will be, okay, 1, okay, 2, 1 function. Okay, 1 to 1 function. And again, I'm going to use, okay, the function f as my general function, okay, to give you the definition or the condition for which a function can be 1 to 1. So a function, okay, f of x is said, okay, to be 1 to 1 if and only if, okay, and here, look at the condition, okay, f of a should be equal to f of b. And I'm introducing you to, okay, maybe a new symbol, okay, a equal to b. Okay, but you don't end there, comma, okay, a b, I will explain a b belonging to the domain of your function f. Okay, and the domain of f, okay, it can be written as dom, okay, of f. Okay, we'll do the domain and range, but I can, okay, walk you through this or teach you this without necessarily taking you through the domain. Okay, so this is, so instead of in some books, instead of seeing the whole of this, okay, you see this. It's where the domain of what of f. Okay, however, when you are reading, you read it as what dom of f, but it means the domain of what of f. Okay, as simple as that. Okay, however, I have written it in full. Okay. So this is what we have. So as we are dealing with it, okay, please, before we even come to that, okay, is this notation here? Are you familiar with this notation? Is it new to you?
Yes.
It's new.
Yes.
Okay, very good. No problem. I'm going to make it. I don't want to tell you. I want you to indirectly, okay, get it yourself. Okay, what is this notation?
Mr. Hackman,
Yes, please.
please, I can't see the screen well.
Oh, please. Okay, who else cannot see the, or who can see the screen very clearly? Akia, can you see clearly?
Yeah.
Okay, then it means, Irene, you have to disconnect and reconnect. If you can't manage. Okay, all right. So it means the problem. Okay, what is the name given to this symbol or sign that we have here? Oh, you should know, you've been using this sign.
The implication sign.
The implication sign, very good. Okay, so what about this? If I do this, what name will you give to that sign as well? Hello, can you hear me? What name can you give to that sign? Wow. Okay, anyway, it's the same implication sign, only that they are looking at different directions. I hope you get it. They are looking at opposite directions. Okay, however, if you look at what we have here, okay, this is a combination of these two. So an implication sign and implication sign, combination of two implication signs. Okay, so let's see, in math, okay, anything that is two, okay, what are the possible names that we will give to that quantity? If you see two, okay, what are the possible names that in math is attached to whatever that you are dealing with, if you are dealing with two same quantities? Hello?
Equivalent.
If something is two, okay, what word, okay, comes to mind? English word. You can get by.
Die.
You can get by. Then which yes, okay. Can we use this as well?
Mm-hmm.
Okay, so if you see this, what comes to mind? Two, is that not it? If you see this, what comes to mind? Two. I hope you are with me.
Yeah.
If you see the prefix by or geo, you know what should come to mind. I mean, what should come to mind. So in the same way, it's the same thing. You see, implication, when you put them together, it's a by implication. So this symbol that we have here, okay, is the by, okay, implication sign. I hope I'm clear enough. So I'm now going to read what you have here. So a function f of x is said to be one-to-one if and only if f of a. So you can see that this time around, I'm using a different letter. A, I'm feeding my function with a different input. A, okay, is equal to f of b. My function fed with another different input, b, by implying that a must be equal to b. And you can see that I have introduced two, okay, different letters, A and B. And you know, just as I told you when we were doing binary operations, okay, I told you that any letter that you introduce, you have to let us know where it is coming from. That's why you said a binary operation is defined on a set of real numbers. So if you introduce any element, let us know where the element is coming from. So with this one, we have introduced input. So we have to let the person know or let us know where the inputs are coming from. Okay, so in this case, your input must come from the domain of the function. It shouldn't be outside the domain of your function. So as simple as that. Okay, we are saying that f of a must be equal to f of b, and you should be able to move on. It's very easy when you start dealing with, only that I'm just throwing a little light on, okay, whatever we have here. F of a should be equal to f of b. So you form an equation. After forming your equation, you should be able to move on to show that A is equal to B. Okay, or after making A the subject, forming this equation, your A must be equal to what? B. And if you see by implication, it means you can work in this direction and equally work in this direction. However, we are going to work in this direction. So I won't talk about this direction. Okay, until I realize that maybe this direction is perfect, we won't go this direction. But it's very likely I will end at this direction, because even if I teach you this direction, you always go this direction. So I will be walking through that. So please take note. For a function to be one-to-one, okay, that is the function f. Your function paired with a letter A must be equal to a function paired with a letter B. Okay, and you should be able to move on after forming your relation. You should be able to move on to show that A is equal to B. Or after making A the subject in that relation, which will contain A and B, you should get A to be equal to B. However, once we have introduced two different inputs, let us know where the inputs are coming from. Okay, and the inputs, which are your objects, okay, you have to attach that they are coming from the domain of the function f, or the domain of f of x. Is the same thing. Is my point well made?
Yes.
Okay, I think I've said enough. Okay, so let me see. All right, so I'm going to clear the whole of this. Then we'll start looking at the first example. How many minutes? Okay, 5 minutes. We should be able to do something. So I'm now going to look at solution to question 2. Okay, question 2. Determine whether or not the following functions are one-to-one. Okay, so we are going to make that determination. Okay, so A. So 2A. What am I giving? I am giving, okay, f of x, the same in the arrow form. However, I will extract in the relation form, f plus 2. Okay, so we are going to state the condition. All right, so we want for a function to be one-to-one. It comes with a condition. So let's state the condition and let the condition guide us as to what to do. So you write for, okay, your function f of x to be, okay, and one-to-one, you can write it this way. Okay, or write it this way. Okay, however, I usually, okay, write it this way, just for, okay, the sake of time. So what do I do? One-to-one. Okay, my f of A should be equal to f of B by implying that A is equal to B. But I don't end there, comma. My AB must belong to the domain dom of what? F. Or domain of f of x, but you can choose not to bring the f of x. F is the same as your function f of x. So please take note. All right. Okay, so let me see. Okay, we should be able to. So this is what we are going to do. Okay, so now I'm going to write but f of A. What is the meaning of f of A? How do you get f of A, knowing f of x?
We
Hello.
replace x in the function with A.
Very good. So it means now my f of A, which is this side of my relation, will give me A plus 2. And that must be equal to f of B. F of B means wherever you see x here, it is equally B. So B plus 2. Do you agree? Hello, do you agree? And remember in what we have here, it said form the relation, then move on, okay, to solve for A. And solving for A, you should get A to be equal to B. So we are now going to make A the subject. Or yeah, solve for A. So in this case, if you are making A the subject, you are going to get what? This implies that A will be equal to. Okay, so what do? You know that this 2 and this 2 will cancel. Or I'm making A the subject, so I'll move this one to the side. So I'll get B plus 2 minus 2. So I'll get A to be equal to B. Okay, so after forming my relation, I've been able to move on to show that A really is equal to B. So once, okay, forming the relation, I've been able to move on to get this side, okay, to be exactly what is here, then I draw the obvious conclusion. So therefore, the function, okay, f of x is what? 1 to 1. Okay, and here, because the conclusion, the reason is plenty, you can choose not to attack. Okay, just leave it. Instead of writing, okay, you can see the condition. Instead of writing f of a is equal to b, that implies that a is equal to b. For a, b belongs to it's long, so you can leave it. Just conclude and don't give it any reason. It's my point well made. We'll do more. So if you are not there yet, don't worry. We'll do more, but you definitely get it. This one is just about the condition and evaluating and change of subject. That's all. Okay, so let's disconnect and come back for our last session. Okay, and round up with the one-to-one function.